Okay.
All right, guys, settle down. Start.
So, morning, everyone. I'm Emiliana. I'm from Group 11, Project E, and I'm going to start the presentation with our topic, which is build tools, continuous integration, and continuous distribution. And I'll talk about the tools, and after that, Alex will talk about how we used them and implemented them. So what tools are we going to talk about? Well, we're going to start off with build tools and then talk about continuous integration and distribution. And first of all, what are build tools? Well, that's tools that you need to automate your build, and basically they take the steps that you need to repeat multiple times during your development process. So the first tool that we're going to use is to talk about is Babel. It's a transpiler, and what it does is basically it allows you to write code in ES6, which is the future version of JavaScript.
That's the current version.
What? What do you mean? I've heard it's coming.
2015 came out.
Right, so shit.
Browsers still don't support it.
There's no support, but essentially that's the current standard.
Okay, so then.
That's why we need actually Babel.
So, okay.
Just to put things in perspective, so ES5 was the dominant since the mid-2000s. And then essentially ES6 came out after ES5.3 Harmony, and that happened in June of 2015. So right now the current standard is ES6.
And 7 is coming up then, or, right?
I don't know.
What is ES 2015 then?
It's ES6.
ES 2015, is that ES6 as well?
I think it's the same thing.
2015.
From what I read, it's the same thing. But then again, you just corrected me. Okay, so anyhow, what it's used for is to translate ES6 to ES5 because, at least at that time, it wasn't supported by the browsers. And it allowed you to write code which was not yet supported. So basically it works like a translator. Here we see an example of ES6 JavaScript and how it is, I hope everyone can see from here. This is what it is translated into, which is ES5. Right, so the next tool we're going to talk about are bundlers. Well, bundlers are used to bundle modules. And what a module is a fully functional piece of code which is independent. And a bundle is a set of modules that you combine together with a bundle. And the idea why we do this is that it basically eases the loading of JavaScript, because instead of loading, for example, 10 JavaScript files, you can just load one or input one in your HTML code, for example, a simple example. And the idea behind it is that it's supposed to achieve a modular architecture on the browser side, following the example of modular architecture on the server side, for example, NPM. And an example of a bundler is Browserify, and it uses CommonJS to declare dependencies, and this is an example of the code. And basically this app is going to use this app. So what's specific about Browserify and CommonJS is that it uses synchronous module loading, which is not that good for the front end and for the browser. And It also needs a task runner to run. I'll talk about Webpack in a second, but yeah, that's the comparison. We mentioned yesterday that Webpack doesn't need a task runner to be used. What is actually that's important for Webpack is that it uses CommonJS and AMD as well, which means that it allows synchronous and asynchronous module loading. And here is an example of asynchronous module loading, and that basically allows you to have on-demand dependencies and to load modules on demand. And that eases your code or the loading of your code, because it means you don't have to load the complete code. And Dimitri, you look quite unhappy. Oh, okay. So you don't have to load all of your code if you're not going to use it right away. You just load what you need. Also an interesting point is that the module can also not return anything. And both bundlers support code splitting, which also eases the loading of JavaScript on the page. Second. So about Webpack, it has loaders and plugins. And the difference between those two is that a loader can operate on a single file, whereas a plugin can operate on multiple files. And what they do is basically the same what Browserify does, but it can also convert CSS files and images. And as we said, Webpack can also, it doesn't need a task runner to be used, so you can use it as a build tool with a simple setting, which you need to input in the package.json. Yes, the output of your bundle is also called a chunk. And I think that's more or less the most important part about them. And in comparison, Browserify is easier and not that complex. It doesn't need much configuration. In general, they can do the same with plugins. However, Webpack supports also asynchronous module loading. Yeah.
What is that word next to source transforms?
Where?
Wi-Fi?
Glyphify. Yeah.
Is that even a word?
It apparently. I mean, it's not, it ends with ifify because that's how plugins of Browserify end. Yeah, and that makes them also quite complicated to pronounce. There was also Kofeifify or something like that, so I decided to remove it. Yes.
What does that mean?
Well, I think it loads and transforms CoffeeScript to JavaScript. Or do you mean what the word means? I don't think it means anything. I think it's just the name of the plugin.
Okay.
Yeah, you seem like you have a question. Or about, no, not you. This time not you.
All right. Yeah, fine.
Oh, okay. So, next point in the presentation are the task runners that we mentioned. The two most popular ones are Grunt and Gulp. So, similarly like the bundlers, they do the same with a different processing implementation, if I can call it like that. What they do is they run the tasks, these repetitive tasks that you don't want to run yourself every time. And they also run the unit tests. They can do also linting, which is an analysis of for possible errors or problems in your code. The the difference between those two in general is that Grunt uses temp files and Gulp uses streams. And I think this is going to be a bit more clear on the next slide. So here I'm just going to mention that Gulp's API is quite simple. It has only 4 methods. And this is a representation of what the two processes are. Like I said, Grunt uses a, wait, how was it called again? Temp files. So that means if it has to execute a couple of tasks on the same file, it will first execute the first task, for example this one, then it will write the result in a temporary file, and then it will grab that temporary file, execute the next task, and then write to the disk again, which uses a lot of writing to the disk, which makes the process slow. And in comparison, Gulp uses node streams, which makes it faster because everything happens in memory. So it just, and it can also group the tasks. So that means that it writes only once per disk, per task, per group of tasks. And that makes it faster, but that also depends a bit on your application, because if it's a small application, it doesn't really make that much of a difference. So you can say Gulp is a bit faster in reference to larger applications. But these are the two methods that they use, and that's what they basically differ at.
Do you have numbers about the difference in performance?
Well, I read something about, it's regarding milliseconds. But I think the example was regarding a normal app and not like a enterprise application. So, yeah. Another difference between the two is the configuration. As you see, Grunt has a configuration which actually looks like a configuration. And here, maybe I don't know if it's clear, but Gulp uses the code over configuration method or idea, I don't know. And that means that the configuration syntax is quite similar to JavaScript, and it's apparently, depending on the developer, I guess, but it's closer to the JavaScript language, so some of the developers prefer it because of that. Other than that, they basically do the same. They both work with plugins, so I guess it's a matter of choice, which one you would prefer. So, yeah, that's how configuration works. It's just an example. And the next tool we're going to have a look at is the continuous integration tool we used for the project, which is Travis CI. And first of all, to distinguish between the terms, continuous integration comes from the extreme programming paradigm, and it's actually a development technique. So what it does, it also automates your build, or uses the Grunt task runner and the tasks to do that automation of the build. And the build is basically the process where you take your code and it gets compiled, and the tests are also run, and it can also generate data or reports. It just takes your code and turns it into a deliverable product, so to say. So what are the advantages of using this kind of a tool? Well, the general practice is that you commit small pieces of code, and the process makes it easier to spot errors and bugs, and since they're small, it's also easier to fix them. And as we all know, it's also cheaper to fix them because you catch them in a very early stage of the development process. So that are the advantages. And
you were saying that Travis would compile our JavaScript into executable or binary format?
I read it somewhere. I mean, I think that's how they described this process of continuous integration, to take the code and compile it with the existing code and have a working code after that, meaning having a successful build.
Okay.
Yep.
Machine code, what do you mean by that?
Well, executable code, a code that you can run. So working code, so to say.
Yeah, it's more not about JavaScript, just maybe for like C# or Java. So yeah, with JavaScript there is actually JavaScript is also already have executable code.
Like a scripting language.
Yeah.
If you replaced executable machine code with code ready to be run on a Jarvis platform, I wouldn't have any questions.
Oh no.
Because when we're talking about compiled languages like C or Go, yes, we need to do the binaries. But if we're talking about interpreted languages like JavaScript or, I don't know, Ruby, then there's no process of compilation.
Well, what I mean by compilation is more like the merging of the new coming code
I
to the
don't
old.
mean to be rude.
No, don't.
I really don't care about what anybody in this room means by compilation. We have a strict definition of compilation. And we don't need to invent new entities.
Okay, then bad choice of wording. I'm just trying to explain what I actually meant, since it's causing...
Right, so just to unconfuse things over here.
So yeah, we just need to replace executable machine code with making code ready to be run on a Jarvis platform.
Okay, do you want me to correct it now? I don't know how much it's disturbing you. Okay, any other questions, or I don't know, something to say? Okay, so this is a representation of the whole process, how basically what I just described with words. So you commit your code and you push it to Git, and Git triggers the build process at Travis, and if the build is successful, you get, of course, the green light, and then if not, you get red light. Simple. These are additional options that you can actually integrate to Travis, which I find quite interesting. This is Code Climate. It's used for automated code review, which is quite an interesting idea. Yay! I personally haven't seen it or heard of anyone using automated code review, so I don't know how exactly that works and if it's a good idea, but it's an interesting... Sorry?
We use it in production. It's a tool that is trying to do static analysis of your source code. And it has a predefined set of rules, so it's going to tell you, for example, I don't know, you have a gut-like method that is 500 lines long, you know, so you better split that into chunks. Okay. Or you got a cut smell right here because your public method of this class is trying to use objects of 3 other classes. So that is, again, that means you're violating separation of concerns. So you can config it to adhere to solid principles of object-oriented programming, and basically just about anything you can come up with. It's a very solid tool.
I guess just how I know of code reviewing, it's done manually, so for me that's a bit like magic still. But it's an interesting thing to know that you can integrate, I guess. And another additional tool I came across that you can integrate with Travis is Coveralls. It does code coverage. I mean, how much code your tests are actually covering, meaning how good are you actually testing. So this is how it looks. And the last point I'm going to talk about is continuous deployment and where the difference is to continuous integration. Well, continuous integration, from what I've read, and I've read quite different opinions, but I think I like this one best. Continuous integration basically stops till here. I don't know if it's readable, but yeah, it's quite small. However, this is the test phase, and this is release. So continuous integration stops here, and continuous deployment stops here. That means continuous deployment is the possibility to deploy your code if your build was successful directly. What are the advantages of continuous deployment? Well, it saves the time to market, it automates the process, and it's also done in small chunks of code, logically. So also if it causes any problems, it's easier and fast to fix. And this is where it fits in the process. After your build has been successful, for example, in our case, the NPM packages get uploaded to NPM, and okay, we're not using Heroku, but I decided to just show it as an example. The successful build triggers the deploy to Heroku, and your customers can enjoy your product. And that was all. And now Lauren is going to talk about testing framework.
One quick question. We did all these guys including vignettes.
Yeah. So I will tell you a little bit about testing frameworks. We choose to talk about these 5 or 6 testing frameworks, starting with Mocha. Mocha is one of the newest of those 3 unit test frameworks. It was released in 2012. It's running on Node. It features asynchronous testing, which is a headache in JUnit, and so it's pretty simple to test asynchronously, and it also reports the test coverage. Assertion library in the official documentation is should.cs. There are also like express.js, but that's the official used library. A quick example would be this function. So you have like these describe things, which are the test suits. Then you can have like a subcategory test suite. In this case, it's the index of function. So here you have the array itself. So you tell that you are going to test arrays. Then you tell you're going to test the index of function. And then you have these tests. They always start with the it. Like you read it, it should return anything. So in this case, it should return -1 when the value is not present. And this one will return 1 because the number 2 is at the second place in the array. And because we start counting from 1, the second item is on place 1. And here the 0 is not in the array, so it returns -1, and that's what we want to have here. So the next framework is Jasmine. It's not the oldest of them. It was released 2010, and it's probably very easy to use. Like you have a function, in this case the hello world function, and you have the same syntax like in Mocha, where you describe your test suite, and then you have these tests. Like in this case, we use the expect function of the function hello world, and this should equal hello world. And yeah, in this case, hello world and hello world are equal, so it will success. Then JUnit is, or QUnit, not JUnit, sorry, is the oldest of these three frameworks. It was released 2008, and therefore the other two did some stuff right which KUnit did wrong, like asynchronous testing with QUnit is very, very hard and not straightforward. But since the release, it's heavily used by jQuery, like the jQuery developers use it to test their library. And yeah, it also supports server-side and client-side environments. So a quick example would be this code, where you describe your test here in the first item of the function, and then you have these little functions like OK, which tries to figure out if the Boolean is true or not. If it's true, it will pass. If it's false, it will not. It will fail. And yeah, then you can also compare strings like in the other frameworks. That's done like this. So another example, which is not unit test, is in this case Casper.js and Phantom.js. Phantom.js itself is a headless browser. Headless browser mostly used for testing, or you can also, if you want, do a DDoS attack with Phantom, very easy. So Phantom.js is the browser, and Casper.js is used for the testing part. So you have a syntax like this, and you can use all functions of Phantom.js also in Casper.js. So at least you don't need to first declare Phantom parts. You can directly use them in Casper. So in this case, we take a look at the Google domain, and with this method we get the title of this page, and yeah, here we compare it if it's the same here, like if the title of google.com is Google, and that's the case, so this will also pass. It's very good to test websites, and you can not only test title, but you can also take screenshots and test the code of the page, and it's pretty cool to test web pages. The last framework we use also in our project is JSHint. It's basically used for code quality. This is an example output. If you
quality is horrible, we can't frankly see anything.
Oh yeah.
Okay. Then I try to explain it.
Example output, nonsense.
Yeah. You can basically see that like here, if you compare something with undefined or null, you should always use the strict kind of comparison. Like if you have a 1 and only 2 equal signs, and you have the 1 in encapsulations, it will be true. If you use 3, it will be false. So only if you have 1 and on the other side also only 1 without anything else, it will be true. And this text tells you that you also should use this for undefined and null, for example. Or if you're missing a semicolon at the end of any function, it also tells you that you better should use 1. Yes, in our project we only use Mocha and JSHint so far, and that's the part which Alex will tell you about.
Question slide 27, where with the Casper and Phantom. You said that you can use Phantom JS in the Casper.
Yeah.
So is there actually any Phantom in there right now, or is this just all Casper?
I think that is only Casper right now.
Yeah, so you can use Casper alone or with Phantom.
Yeah, I was just wondering if any of this was actually like code from Phantom JS or if it's all Casper.
I don't think so.
This is Casper.
Okay, so since we started talking about this slide, what should I use? Should I use Casper JS or Phantom JS? How would I choose?
It's like both. If you want to, so if you already have a page in World Wide Web, you can use Casper to like test it. But if you want to create this page, you can create it with Phantom JS, like emulate the browser, and then test it with Casper. So you don't need to deploy it.
How do I emulate the browser? Like how do I configure which browser I want to emulate?
That's a good question.
What can I say?
How do I configure, what is that, Casper to for the browser, the vendor end version that I want?
I think you can configure it like you say you want to use WebKit and version, I don't know, 40.
And this would be where?
I think, but I'm not sure about that.
Okay. In Phantom, we're essentially, okay, I understand that it's a headless browser, but what is the advantages that it gives me?
We thought it will be nice to talk about because we have this integration. So we actually integrate C10 with front end.
Yeah.
So we could test it with. There was a possibility to test it with it. Actually, to test how was front end integrated. Mm-hmm. So if the map edit, model edit, so we actually can test it with Casper after integration. Just.
You can have JavaScript interactions. You can call JavaScript functions in Phantom.js using Phantom.js.
With using what?
And the Phantom.js provides a browser, so you can call JavaScript functions in it.
Anyone can answer, like, what is the advantage of using, what are the advantages of using a headless browser over testing in a browser?
Define testing in the browser, like manually loading a page and then clicking
No,
on
I mean, this is the distinction here, right, between Phantom and Casper. Why would one choose a headless browser over automated web page testing?
Because you don't have to like use the mouse to click on stuff. Because like, I think like testing frameworks like Selenium actually move the mouse and click on the UI, while headless browsers use a CLI to interface with the structure of the web page.
Okay.
Does that make sense?
Yeah, totally.
And you can also run it on a server that doesn't even have a graphical user interface. So you will not be able to run a browser.
It doesn't have an X server, for example, to run the UI. No.
Right. Now, Yasha, you had your comment that you just told me?
Yeah, you can call click functions on JavaScript, on HTML buttons or something, and call the JavaScript inside using Phantom.js. And I don't think I don't know how Casper.js is doing, but probably only fetching like the HTML document and getting like the title or something. And in the Phantom.js you can additionally control the browser. It's like a browser, yeah.
Right. So essentially, you do away with the with all the mechanics that are built into a GUI interface of a browser. You just move them away, and you're actually just interacting directly with the code with no kind of like an intermediate or broker in there. That's the whole idea of the headless browser.
Okay, so I continue with project presentation. The overview is like I will. Okay, let's start with the idea. Idea of our project is to provide easy and continuous and automated integration of all projects. So actually, after push in the GitHub or pull request, it will be built, tested, and published to NPM. So, and we like the team who push the solution, who push the project to create a solution. And also the projects are self-descriptive, so you can go to the Travis and check the build and see what was the problem, is there was some problems or not. Then the tools and the workflow. First we set up Travis for continuous integration. In the same time we use NPM for packaging. We create the package JSON. Then we added Grunt for running the tests. So for this, and we actually added JS hint first, so we can like code quality testing. Then for some project we use Webpack to create the bundles out of many JavaScript files. And the next step will be test all together with unit test and API tests with Mocha. So how it works actually, after every push or pull request, Travis starts to install npm and node and npm. Then Travis run npm build, which start the Webpack and it built the projects. Then Grunt, then Travis run npm test, and Grunt start to test. Start tests of JS hint and Mocha, and in the end, if there was no problems during the build and testing, so all tests passed, Travis run npm publish, and solution will be published to the npm. About npm, the main criteria are that the package name starts with God, and it has configuration, so you can easily provide configuration object to configure the MongoDB or API location. So just you run the config function, give it object with API location and API token, and then init actually inits all JavaScript with all the configurations. The Travis small instruction how we actually set it up. First we created the npm user account with npm end user. Then we install Travis CLI and run setup npm, which created actually this deploy configuration for deploying packages to the npm. Also, we decided not to publish it after every push. So for now, it fails if programmer didn't change the version of npm package, didn't increase it. So if you want to actually publish it, you need to increase the version of package after your commit. Next is Webpack. So we used it in C10 for it's actually the C10 configuration. So how we need to set up, how we can set up the Webpack is to specify the configuration file, which is this one, and we need to download loaders and plugins. So now I will explain more about configuration. So first we set up entry points, which actually Webpack building the tree out of JS files. So first it loads the entry point, then if it requires some more JavaScript files, it added like subnodes of these entry points. Then if subnodes require more JavaScript files or CSS or image files, it also adds subnodes to these subnodes and like configure a tree of requirements of a tree of dependencies of JavaScript files. And output it all to the builds path in our case. So loaders, we need to specify loaders for different types of files. Actually, as it was said, Webpack can create JS file out of anything. So you can create it out of images, CSS, LESS, fonts, out of everything anything you want. And plugins, with plugins you can just, for example, uglify and minify all the bundle after it created. So, and our next steps is to set up a MongoDB instance on Travis. So we can, during the build, the MongoDB will be created on Travis, and we can test actually export from the wiki and API requests.
This is for project A, right?
Yeah. And API tests. Actually, we use Mocha, Shoot, and Supertest for API testing. This is already existing test from project A. We use Shoot. Shoot is like assertion library, and Supertest it add a fancy shortcut for fancy path shortcuts. So we can just configure API and then API post to characters. So it is like done in easy way with these tools. This is distribution of work. We actually, I have C10 and B7. Florian has project A and project F, and Emiliana has project F and do the final report. So that's all. Like, do you have any questions, Dmitry?
Okay, let's go back to bundle. So why exactly do I, as a web developer, need to bundle my files? Why can't I just, I don't know, include, load in that one by one in my HTML file?
Like we used bundlers in C10 because it has a lot of when you have a big amount of files, like a big project with 200 JavaScript files, it would be nice to not load it like 200 files in every page, but to bundle it like in two big bundles and actually load these two bundles together. Also, it has some dynamic loading or something like that, so it will be faster with bundles.
Basically, it's speed. If you bundle it, you load one file, and
that is faster because?
Because it is faster than loading 200 files.
If I'm not wrong,
Come on, what is faster? Drinking 1 cup 100 millimeters of tea, or I don't know, 2 cups of 50 millimeters of tea? Yeah.
I think it's because if you load the files separately, you load them synchronously. So that means you first wait for the first file, then for the second one, then for the third one, and blah 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 blah. And then if you load it as a single file, it's just faster because you don't have to waiting to finish previous job, I guess.
And there is a limit on connections.
Ah yes, you have only one HTTP request. And
Each server, well, a server as such cannot handle an indefinite number of connections. So if you're trying to pull 10,000 of small files, the server will not be able to just serve them all. And if it's just one, you are using simply one connection out of the pool of all available connections. Okay, so, and now again, Gulp. So you said Gulp is more like a regular JavaScript code, and why would I as an end user prefer that? So what does it mention for me?
Well, I read somewhere that, for example, if you use Grunt, you need to download the plugin. And if you use Gulp and you want to test a specific, or to do a specific task, which is like really specific for your project, and there is no existing plugin for something like that, you can basically configure it as a code, because the configuration of Gulp is more similar to JavaScript, so you can basically create like workaround.
Yeah, the idea is for Grunt you need to create plugin for your features that you want to, and for Gulp you can just code it.
Now again, Travis, so first you described Grunt and Gulp, these great tools that allow us to do all of this, that allow us to automate all the repetitive tasks, and then you introduced Travis, which allows me to automate repetitive tasks as well. So I'm a bit confused. What can Travis do that Gulp and Grunt cannot? Why would I add it to this?
Okay, I think Travis is the part which tracks GitHub, and so if you have a new commit, Travis will tell Grunt to run. So Travis is the player between GitHub and Grunt, and keeps track of GitHub. Yeah.
One more thing would be you can actually also integrate something like a messaging system with Travis, for example, HipChat, and it can inform your team members that build failed. So it's useful.
Also, Travis is not specific for JavaScript.
Yes.
Yeah, but Grunt isn't either.
What?
Grunt isn't either only for JavaScript. You can run different things. Like you can also test C with Grunt or anything else.
Okay.
But yeah, that's fine.
Do you have an example of a Travis report we can see?
I can actually show it next.
No, you want, here. Or do you want a huge?
I can show a big one.
Just open up the web page.
Yeah, okay.
So now comes the key question. Why do you want to implement these things? Why would you want to have some badge on your code that tells people that your code builds? Why do you want your code to be formatted in a certain way? Why not just keep it, code it, and that's it? Why would you want to do something like this? Why would you want to complicate your life?
Because it doesn't complicate your life. Basically, deploy per click, more or less. If everything goes okay, right? If you don't break the buildings, for example.
Okay, this is nicer.
Well, we're speaking about open source communities, no? So everyone can,
So here is
everyone can write code, everyone can contribute to
actually
repositories. So what is important when everyone contributes to repositories for people that have to download your package, your whatever, and have no idea.
so here is a deploy, which actually okay.
So yeah, I guess this question is for all of you. What is the added advantage of using continuous integration versus just manually doing everything and throwing it out there?
If you have like an open source project and you have maybe you have some people who contribute to that code and you don't know if they can code very well or not, it's at least the basic step is to find out if the code even is valid.
Right.
And if you write like a lot of tests, you can also be sure that the code will work in the open source
Yeah, you
project.
can use code review also in this case.
Yeah. So you don't have to manually review the code, or at least it gives you a hint if the code is good or not.
All right, so you set quality standards for your codes. You said essentially a way to monitor that those standards are being maintained. What else?
Just to build it and test it, not to do it on your machine every time.
Why do we need to continuously build?
To test it and to see what actually we will have in the end.
Well, we work in open source communities, and essentially we're getting code contributions all the time, right? Essentially, our project is essentially a dynamic living entity that keeps on getting new patches all the time. So we need to keep on building it. Having a person sitting and manually building it is probably not as efficient as having this automated. Last thing could be.
Yeah, maybe the part which we are using for the project. So if it's successfully built, we can publish it
Deployment,
somewhere.
exactly.
Deployment, yeah, that's right.
Right. We want to make sure that that once we've essentially we've assured quality, we've monitored that the quality is being kept, and we've rebuilt the source. Now we want to essentially deploy it. Once again, it makes more sense to have this automated than actually do it manually.
Let me just add the last thing for the final user, and in every software development project, the final goal is trust. So you want your people to trust your software, and this is building trust. So this is very important, very, very important.
I think the central part of continuous integration is the integration part, actually. It's not that you have a green mark on your GitHub page that says everything's all right, but it's more that you test while you're developing that the system you're developing and building and integrating from other parts of the internet is actually working together as you would expect. And continuous integration just says that, like in bigger projects, you would pull in several different GitHub repos and build them together and try them out if they work together. In our example, we only build each project. We don't have an integration step yet. So maybe that's for the future, we might think about that as well. How we will do the integration and test that.
What would you recommend? For instance?
Well,
I totally hear you, but I want to challenge you to think about how we actually now do a cross-project integration.
We have to think about that together, I think. How we want to merge into Project F all the other projects. How we want to merge into Project A the other projects. So this is something with the automated publishing of Travis. We want to use that. So what you do is in Project C or B, we would publish a tag as soon as the build runs through smoothly, and in version to master, we would publish the build to npm, and then in Project A, it would trigger a rebuild and test it with the new build or the new version which was just released in npm. And that's your integration part. And you want to do that continuously.
that's actually the perfect, that's actually exactly the goal that should be achieved by the end. I think that's a little bit too much.
Pushing it another. All right, so what are we seeing here?
Here we can see the build just started. Actually,
They made it on purpose, right? It's not that they were coding while we were giving the presentation.
No, they're not allowed to.
so we can see here that it was actually builded. Build and deploy bundles was actually builded, and here the deployment didn't publish because the version was like the same. So if you will change the version, it will be published, as I said in the project presentation. So here we can see actually how the process works.
It's a very nice way of doing this.
Yeah, all right. It's already after 11, so thank you.
I have 2 remarks. I have 2 more remarks. First one is just a quick thought that can you open, just Google it, Gremlins.js. I think it will be beneficial to everybody.
Well,
Gremlins. Gizmo, you remember that movie, Gremlins, yes. Gremlins. Not .js, white space. Okay, open it. Go down. And this is great. There's supposed to be a demo on that page. Small.
Dimitri, we're already 4 minutes over. Is there a purpose?
Yes, wait. Up. Yeah, that's it. So it's a monkey testing library where you load the page in your browser, then you load Gremlins.js library, and there is just these hordes of clicks on everything. It's like random testing. It tries to break your page. And if your page doesn't break, that means you built a really solid app that will not break even in the hands of the most stupid users. Like me! Yeah, so that's the first one. And second, guys, great presentations, but you used font with serifs in your presentation.
What? Okay. I'm not sure. I think it was something else. Something with.
I swear I can see them. I swear.
Well, you can also see the matrix, can't you?
And but no, seriously, there is a huge difference between fonts with serifs and fonts without serifs. So don't use it.
Okay. Interesting remark.
No, it's a good one. All right, so Project F, Gremlins.js. It's going to go on your ratios, I think. All right, I have one last question that I think is will actually summarize this entire thing. So when we started, I think that one of the most misunderstood project was actually Project E. And there's other Project E members here? So this is open for all of you. How would you summarize your role in this? I mean, obviously you weren't doing actual development, you were kind of like, supporting development. So maybe you can give us a few words on, your experience, what it is to actually be able to bring the effort of other groups and integrate them into the larger picture.
I'm not sure I got your question.
Well, so when we started this a few weeks ago, obviously every other group essentially understood what they needed to do. I think that at the beginning there was a bit of confusion about your role.
I think there was a lot of it.
Right. So, having understood now the importance of it, I think that, when we just got into this, a lot of people have just read into Project E. Essentially, this is like about unit testing, and that's it. Hopefully now you understand the importance of actually bringing in integration, and especially in an open source project where you have to actually, as we said, set the standards and set automation and all of that. From your personal experience, what was like the most important part of the work? What do you think would happen if you weren't there?
It will be usually when somebody develops an application, he just want to the main problem is when you, for example, it was for Project F, when you import the map, it doesn't work, and actually it was our work to find out why it didn't work, because the Project F is like, usually if I will get the library, get the package, I don't care why it doesn't work, it just doesn't work, so I will go and put issue on to the project C10. And project C10 see it like it works in their project, so they also don't care why it doesn't work in project F. And that actually is the main idea of our existing this project E, because we need to actually go to project F, understand what they are doing, go to project C10, understand what they are doing, and find out why it actually doesn't work and how to improve it.
All right. Any other experiences or lessons that you've taken out of this? I mean, the other groups are welcome to share as well, if having the integration project has helped them as well. Yeah.
Yesterday it didn't help. We pushed some changes which broke our build, and Travis said it was fine. So I'm not sure like if the testing is really implemented or not, but like. At least what's happening right now is not helpful in that sense, because we don't actually test if the application is start up and test.
So what you're telling us is that essentially just a redundant step that you're not really relying on.
No. Also like.
No, you're not saying this, or no?
Nobody like really paid attention to Travis. From our group, because it was like not working for some time, and then we had some other issues with it. So yeah.
Well, but when you start,
we wouldn't have needed it from the very start. Like, when we start coding, you should like have the integration ready and set up, so it tests like already the first function that you write.
Yeah, but the main problem in the beginning is that we didn't have A and F projects in our actually. Wiki, so we thought that we need to do only for BCD.
Yeah.
Has anyone here worked with continuous integration before? Another project. So, does this exposure to what has been done here convince you that you would want to try this in other in your future projects? Anybody who thinks yes, please raise their hand. Not that many. Interesting.
Understanding comes when, your paycheck gets helped.
What's that?
People will understand the first time their paycheck is helped because of the errors and unhappy client.
That's true.
That's very true.
All right. Thanks a lot. Thank you.